Welcome to another episode of FRC Code Academy. In today's episode, we will explore the basics of robot code with Romis.
Before you run your code on $1,000 robots, it would be wise to hone in your skills first with cheaper alternatives. This is exactly what we're going to be doing today with these little practice bots called Romis.
They consist of a small Arduino control board, Raspberry Pi, and a simple differential drive system. To continue with this series, you'll need to have a FRC compatible development environment, a fully assembled and network configured Romi, and some basic understanding of Java syntax. I have left links in the description that can help you meet all of these requirements. So without further ado, let's get started. To create any FRC robot project, you have to use a special create project command in the WPILib version of VS Code. Once you run that command, a setup wizard will pop up. It allows us to pick between a template or example project. Template projects are mostly empty and only provide the structure for you to code, while example projects are fully fledged codebases that provide the completed solutions to many common FRC coding challenges. We want to create our own Romi code from scratch, so we will select a template project and Romi timed robot. You are also going to need a directory to store your robotics projects. I would suggest you make a folder within your personal user directory specifically for robotics projects. Also, give your project a name and input your team number. After it finishes loading, you'll notice a whole bunch of files have appeared in your project. Don't worry, you'll never have to edit the vast majority of these files. Most of them deal with automating code compilation and managing library dependencies. The source code of our project is just 3 files within the source main Java FRC robot directory.
Even though we selected a template project, WPILib still generated some of the code for us because it knows that most people who work with Romis are beginners. We're just going to delete the code that was auto-generated for us so that we can start from a clean slate.
Now that all of the auto-generated code and comments are gone, we can inspect the robot.java file. You'll notice that it has a couple of methods that are called lifecycle methods. They run at different times during the robot's lifecycle. These lifecycle methods are also split into 2 categories: initializing methods and periodic methods. The difference between them is that initializing methods are only run once, while periodic methods are run 50 times a second. Let's go over a standard example of a robot's lifecycle to show you when each method is run. First, the robot turns on, the robot initialize method runs once, and the robot periodic method runs 50 times a second. And since the robot starts in disabled mode, the disabled initialize method will run once, and the disabled periodic method will run 50 times a second. Then your robot enters into autonomous mode. The autonomous initialize method runs once, and the autonomous periodic method runs 50 times a second. And since the robot is no longer disabled, the disabled periodic method stops running. Next, you disable the robot. The autonomous method stops running, the disabled initialize method runs once, and the disabled periodic method runs 50 times a second. Then your robot enters teleoperated mode, and the teleoperated initialize method runs once, the teleoperated periodic method runs 50 times a second, and the disabled periodic method stops running. Once you turn your robot off, all the methods stop running. Now that you understand what runs our code, we can begin to program our Romi. Our first goal is to make an autonomous routine that spins our Romi in circles. We need to first initialize the motors on the Romi within our code. It utilizes a Spark motor controller, so we're going to have to create a Spark object. Notice that WPILib's auto debugger is stating that there is a syntax error within our code with the squiggly red line. The Spark class has not been imported. To import the Spark class, you can click the quick fix light bulb icon, and the first option lets us import the Spark class from wpilib. This only works because wpilib knows about the existence of sparks. If I were to create a mango object, I would be out of luck. The WPI library does not have a mango class. Sometimes wpilib does not have a class for every component you want to code. In that case, you need to download third-party libraries. However, that is a topic for another time. Okay, now that we have our motor objects instantiated, we will tell them to run during the autonomous periodic method. To see the methods available in a class, you can type the object name dot and a list of methods will pop up. In this scenario, we want to use the set method, which tells the motors what speed it should run at by accepting a double from -1 to 1 as a parameter. Great, now that we have our code, we can run it on our robot. Running code on Romis is a little different from normal robots because they have a different microprocessor. They have a Raspberry Pi instead of a RoboRio. So keep in mind that you'll have to relearn the procedure to run code on normal robots. Anyways, to run code on Romis, you need to connect to your Romis Wi-Fi network and then run the special wpilib command, simulate robot code. And a screen should pop up that is the replacement to the normal driver station. It is essentially the same thing as a driver station, just formatted differently. Once you click the autonomous mode, you'll see your Romi follows your code. Now that the autonomous mode for our robot is done, let's code the teleoperated mode. But first, you might have wondered why the Romi spun in a circle when we gave it positive inputs to both motors. The answer is that the right motor for Romis is installed in the reverse direction. We should not rely on this fact to spin the Romi, so let's correct it within the code, utilizing the Spark set inverted method within the robot initialize method. Now, for both motors, if we give them positive values, they will go forward. So we have to modify our autonomous routine by adding a negative sign. Great, now that we are oriented correctly, let's start programming the teleoperated mode. We will create a joystick object at port 0, which we will use to control our robot. Within the teleoperated periodic method, we will get the desired speed and turn from our joystick with the getRawAccess method. Then we will pass in the speed and turn into the left motor and the right motor. Because the right motor gets speed plus turn and the left motor gets speed minus turn, the speed input will cause the robot to go forward and backward, while the turn input will turn the robot. Okay, let's try it out. To use the arrow keys to control the robot, drag keyboard 2 into port 0 of the joystick ports. Congratulations, you finished coding a Romi in both teleoperated and autonomous mode. If you want an additional challenge, you could try programming your Romi to complete a maze utilizing their built-in encoders. Or you could configure their teleoperated code to work with third-party joysticks like Xbox controllers. Or you could get your Romi to do a figure eight, or any number of things. The sky is the limit. However, that will be all for this episode. This has been Victor Moldavanu from Team 612. See you later, and goodbye.